Yeah, yeah, the last part.
Question two here.
Yeah, question to the last part. Yeah,
So
yeah,
how do we
right
calculate
there.
x1, x2, x3, and x4, right?
Yeah,
Okay, so if you see like I think you can solve this matrix into RRA form because we have done it for a lot of time. And if you don't have time, so you can just use any online calculator. Okay, so for example, I will give you a link, so you can just put the value and you can find the RRA form within 1 minute. Okay, so you don't need to worry too much about the RRA form. Just try to think like what is independent and what is linearly dependent, and what is linearly independent. So we have just converted our matrix into RRA form, and then if then okay, so then if I try to write down like x1, x2, x3, and our beta, so you will see that uh, the first column here, we have so you just look at the first row. Okay, the first row. So for the first row here, our pivot point is 1, and here we have another we have another entries, right? So this 2, it is not our pivot point. Our pivot point is the first non-zero entry of any of any row. So this one is our pivot point. So we can just write down this way, like x1 plus 2 into x4, right? x1 plus 2 is 2 into x4 is equal to 0, because this value beta, it will stay on the right side of our equation. So that's why I have written here x1 is equal to x1 plus 2 into x4 is equal to 0. And then if you take this 2x4 on the right side, so you will find the first equation here. X1 is equal to minus 2 into x4. Okay, and the same way goes for the second row. So here our pivot point is here 1. So on multiply x2, that is going to be x2 plus on multiply x4, that is going to be okay. So on multiply x2, that is going to be x2, and on multiply, okay, here was x4, right? X4. So on multiply x4, it will be also x4. It will be also x4. So you can write down x2 plus x4, x2 plus x4. Oh, sorry, I'm just getting distracted with all the sounds around me. So x2 plus x4 is equal to x2 plus x4 equal to 0, right? We have 0 on the right side. And then if you take x4 on the right side, you will get x2 is equal to minus x4. And the same way goes for the third row. Okay, so x3, we have x3 here, and on here, so on multiply x3, it will be x3, and then minus 1 multiply x4, it will be minus x4. So x3 minus x4, and on the right side we have 0. So x3 minus x4, it will be equal to 0. So that's why I have written here x3 minus x4 is equal to 0, and then x3 will be x4. If you just take x4 on the right side, so you will get x3 is equal to x4. And then at the last row here, this is all the entries, they're 0. So we can say that this row, this is free. So I have written here x4, this is free. So now you have to just calculate the rank. So this matrix, it has a rank of 3. Okay, I have already calculated them before. Like we have the 3 pivot point here, so that's why our rank of this matrix, it is 3. So as the rank of this matrix is less than the number of column, so we have 1, 2, 1, 2, 3, 4, 5. We have 5 column here, right? So as the rank of this matrix is lower than the column, so we can say that this is, if you look here, so rank is lower than the column, so you can say that this matrix is linearly dependent. These vectors are linearly dependent. Okay. Okay, Alamin, no problem. Alamin is on the bus.
Yeah, Allah Hafiz, brother.
Yeah, it's okay. I will send the recording on the YouTube channel. No problem. So I'm just getting distracted with all those sounds around me. Okay, so it makes me really. First of all, I'm really tired, and then. Okay, so guys, can you understand this? Hello, Mitchell. Uh, so can you understand now?
Yeah, I got it though. Thanks.
Okay. So let's continue to the next question. So we have to calculate the rank of the vector alpha 1, alpha 2. Sorry, yeah, alpha, here will be alpha 2. Alpha 1, alpha 2, alpha 3, and alpha 4. So then find the maximal subset of independent vectors. So finding rank is very easy, okay? You just need to find the RRF form and then see the pivot point. So we have first pivot point, second pivot point, third pivot point. So we have 3 pivot point. So the rank is 3, okay? One, two, three, four, five. Or you can just so you see I have written like the rank of A is less than or equal to minimum of the number of row and the number of column. So we have 1, 2, 3, 4, 5 row here, and we have 1, 2, 3, 4 row here. So in between 5 and 4, the minimum number is 4, right? So we can say that the rank will be less than or equal to 4. So now we find the RRF form, and then we see that our rank is 3. So this way we can find the rank of a matrix. And then, so I have written here the RRF form, the number of pivot point are 3. So the rank will be 3. And the maximal subset of this independent vector is alpha 1, alpha 2, and alpha 3. So, okay. If you look here, we have a maximal subset. So we have 3. Okay. So we have 1, 2, and 3. We have 3 equation. We have 3 rows. They are okay. If I have written here. So if you look on the third question, I have written here like x1, x2, and x3. They are basic variable, and x4 is free variable. So you have to see the basic variable and free variable. So here we have 1, 2, and 3. We have 3 basic variables, that is alpha 1, alpha 2, and alpha 3, right? And then these 2 variable, they are free variable. So because they all the entries of this two row, they are 0. That's why they are a free variable. Okay. And our pivot point is our pivot point is here on the first 3 row. So we can say that the maximal subset of this independent vector is alpha 1, alpha 2, and alpha 3 because they are containing the pivot point. Okay, guys. And now let's continue to the next question. So can you understand this one? Okay.
Yeah, brother.
Okay. So the fifth one here. Suppose that alpha 1, alpha 2, alpha 3, alpha 4 are linearly independent. Then determine whether alpha 1 plus alpha 2, alpha 2 plus alpha 3, alpha 3 plus alpha 4, and alpha 4 plus alpha 1 are linearly independent and show the reason. So if you see here, we have alpha 1, alpha 2, alpha 3, and alpha 4. And for here, we have added extra alpha 2 with the first one, and then we have added here alpha 3 with the second one, and we have added alpha 4 with the third one, and also alpha 1 with the first one. So I can just if they are independent, if they are linearly independent, then so if they are linearly independent, then k1 alpha 1 plus k2 alpha 2 plus k3 alpha 3 plus k4 alpha 4 is equal to 0 has on trivial solution. That means if they are independent, then they will have only on solution. Okay. So now we have to see if they are independent. So now we have to look at for which condition they are linearly independent. So this is the condition. Okay, k1 alpha 1 plus k2 alpha 2 plus k3 alpha 3 plus k4 alpha 4 is equal to 0. So here is the alpha 1, alpha 2, alpha 3, alpha 4. So we just multiply k1, k2, k3, and k4. Okay. So and then in our question, this part alpha 1 plus alpha 2, this part is here. So they are linearly independent if we have to replace this alpha 1 with this alpha 1, alpha 2, and we have to replace this alpha 2 with alpha 2 plus alpha 3. Okay. So we have to replace alpha 3 with alpha 3 plus alpha 4. So this way we replace here. Okay. We replace here. Now we get this equation, and it is equal to 0 has on trivial solution. So if I just okay, if I just multiply k1 with alpha 1 and then k1 with alpha 2. So if I multiply all these, okay, k2 with alpha 2 and k2 with alpha 3, and then if I just take alpha 1 as common, okay, if I take alpha 1 common from k1 and k4, okay, let me show you here. This is a long process, but you can just imagine here. So we have k1 here. Oh shit. Okay, we have k1 here. We have k1 here. So and k4, we have k4 here, right? So if you multiply k4 with alpha 1, you will get k4 alpha 1, right? K4 alpha 1. And then if you multiply k1 with alpha 1, so you will get k1 alpha 1. And then you can just take this alpha 1 and this alpha 1 as a common, right? You can just take a factor out them. Okay, so that's why I have taken alpha as common. So we get k1 here and we get k4 here. So I have written here k1 plus k4. Okay, so this way you can also if you take alpha 2 common, so you can get k2, and also here is k1, right? So you can also get k2 and k1. And for alpha 3 you can get like k3, right? And also you can get k2. Okay, for alpha 3. And for alpha 4 you can get k4 and then k3. Okay, so you just can imagine like how I did this part. You can do it in your brain. And then k1 plus k4, they are, you can just let their c on, and k1 plus k2 you can let c2. Okay, they are just some constant. So now now you can just write down this way, like alpha 1 into c on, then alpha 2 into c2. Okay, because we have already calculated those parts. So alpha 1 into c3, then alpha 4 into c4. So this is the line, and then we can see that k1 plus k4, they are some constant, right? Because we already took them as a constant at the first stage. Okay, they were outsider. Okay, if you look here, this k1, this is also constant. Okay, so the last line here, we can say that c1, c2, c3, c4, they are all constant. So that's why our alpha and alpha. So that's why this. That's why here is in our question. here are in our question this part. Okay, so this part, they are linearly independent because if C1, C2, C3 and C4, if they are constant, and if their multiplication is 0, so we can say that this whole vector, okay, they are also linearly independent. Okay, right. So guys, I think you can understand like how we explain this part. So see here, we had at first we had k on alpha 1. So this line was the condition for any linear system to become independent. And then for k on, at the last part we got c on, right? So this c on alpha 1, they were also 0. That means we can say that alpha 1 plus alpha 2 and alpha 2 plus alpha 3 then alpha 3 plus alpha 4 and alpha 4 plus alpha on, they are linearly independent. So I think guys, can you understand? Yeah, I think so. Why we use augmented matrix to prove it independent? Because augmented matrix are much more easier, okay, so to calculate, and we can just convert it to RREF and we can come into a solution. That's why we use augmented matrix for to prove the linear system, that whether it is independent or dependent.
No, I just said, why don't we use in this particular solution?
Oh, okay, sorry, okay. So why don't we use A here? Because, okay, because
Yeah.
here we don't have any number, right? Because we don't have any number here. So
Okay, we don't have any value, yeah.
Yeah, we don't have any value here. So we just we just multiply k1, k2. Those are our constant.
Just a variable.
Yeah. So there are some constant. Okay, k1, k2, k4. So that's why I think okay.
Okay, got it, bro.
Yeah. So right. If we multiply all k's with brackets and then take alpha common. Yeah, right. So okay, so if you multiply all k's with brackets and then take alpha, which alpha common, alpha 1 or alpha 2? So alpha 1 common, alpha 2, yeah. So we did the same thing here, as Zakira told. Like if you see here, I have skipped a part, right? I have explained that. So if you multiply, if you just break down this line, so you come into a conclusion. Like you can just take out the alpha, all the alphas common, like alpha 1 common, alpha 2 common, right? So as you look here, I have taken alpha 1 as a common, alpha 2 as a common, alpha 3 and alpha 4. So yeah, Zakira is right. So guys, did you understand? Okay, so we can continue. Okay, so here's the end of homework 5. Okay, so now let's talk about the test paper. Okay, so what is the test paper? Let me open that. Test paper. Test paper 2. Test paper, yeah, I got it. So here is the test paper. So guys, can you see my screen?
Yes, bro.
Okay. So let's see the first question in the test paper. So we will have around we have a examination of 100 marks. So the first question here is if E a matrix that is this way, and then we have changed this matrix into some kind of we have done some row operation, and now the matrix is this way. Okay, so if you look at the changes, the changes is here, right? Like okay, the changes is here, 7 7 7. So that means we have multiplied a7 with the first row. Okay guys, so we have to find E. You have to find the E. So if you look here, we have multiplied 7 in the first row, and you have to write down the corresponding identity matrix. Okay, as you see here, as you can see here, I have written, so it is a 3 by 3 matrix, right? 1 2 3. It is a 3 by 3 matrix. So I have written here a 3 by 3 identity matrix. Let me change the color. So you see here, I have written a 3 by 3 identity matrix here, and then I have multiplied 7 with the first. I have multiplied 7 with the first. I mean with the first row. Okay. So if you see here, I have multiplied 7 with the first row, and then I got 7 0 0 and 0 1 0 and 0 0 1. So this is our answer. Okay. So this way we find the this way we find E. We need to see the changes, and then here we can see like we have multiplied 7, and then we have to write down the corresponding identity matrix. So here is the corresponding identity matrix, and then you multiply 7 with the first row, as you have seen here. We have multiplied 7 in the first row, so the answer is here. Okay, 7 0 0 0 1 0 and 0 0 1. Now let's see E1, E of A, right? A21 plus A11. Find out the row operation, then perform the same operation. So this is the rule, like find out the row operation and then perform the same operation with a identity matrix. So you don't need to think of this part. So I don't know what Laos tried to explain here. So you can just skip this part. Okay. Now let's continue to the next question. So here we have A is an n by n matrix, then k of the norm of k multiply A is hot. So according to the properties, so if you see vector properties, so there is some formula. Okay, so according to those formula, A is an n by n matrix, then k the norm value of k multiply A, it will be k to the power n. It will be k to the power n multiply norm of A. Okay, so this is just like a formula, like as we know, like a plus b whole square equal a square plus 2b plus b square, right? Those are some formula. So that way, this question is it is also, the answer is also a formula. So if A is a n by n, that means if A is an a square matrix, so norm of k multiply A, it will be k to the power n multiply the absolute value of A. Okay, so I think you can understand. This is just the formula. So now the third one here, if determinant of A is equal to, and then determinant of B is equal H, so then we have to find determinant of A B inverse. So, okay. So determinant of A is equal to and determinant of B is equal 8. Then determinant of A B inverse. So from the formula, it will be determinant of A into multiply determinant of B inverse. Okay. So you can just remember this way: you multiply the determinant with A and also determinant with B inverse. So now, if you look here, B inverse. So we know that A to the power minus 1. This means on by A, right? A to the power minus 2. It means on by A square. So this is some simple algebraic formula. So B to the power minus 1, or I mean B inverse, it will be, so determinant of B inverse, it will be on by determinant of B. Okay, guys, maybe you know this formula. So any number or any variable with the power of minus sign, it will be on divided by that variable. Okay, that variable with that power. So that's why I have written here determinant of B inverse. It is on by determinant of B. So now you just substitute the value. So determinant of A is equal to, so I have written here 2, and then determinant of B is equal 8. So I have written here 8. So the answer is on by 4. Okay, guys, can you understand? Okay, yeah. So now let's go to the next question. The matrix A is equal 3, 5, 2, 3. Then what is the inverse? So for a 2 by 2 matrix, finding the inverse matrix is very simple. Okay, just so just follow this rule. Multiply the first the first corner, and then sorry, exchange. Okay, exchange the first corner. So A will go here and D will come here. Exchange the position of the first corner, and then multiply a minus sign with the second corner. So if you look here, I have written them. So multiply a minus with the second corner. So this way, like we have 3 here and we have 3 here, so we can just change those position. So I will get so before so I'll get 3 and also 3 here, and then I have to multiply minus sign here and also here. So I'll get minus 5 minus 2, and then before that we need to write down on divided by the determinant of the matrix. Okay, so the determinant, so how do we find the so how do we calculate the determinant? Determinant is a value, so you have to multiply this way from upside down. So 3 multiplied 3 is 9, and then minus 5 multiplied 2, that is 10. So 9 minus 10, that is minus 1. Okay, so you write down here that on by minus 1. So this way we can easily find out the determinant of 2 by 2 matrix. So you can find out the inverse. We can find out the inverse matrix of a 2 by 2 matrix. So the formula is here. On by determinant of A, and then you have to just convert this way. I hope you guys can understand this part. Okay. So let's continue to the next question. The matrix A, okay, so if A is equal 1, 2, 3, 6, 5, 6 and 2, 1, 5, then what is the transpose of A? So what is the trace of A? Okay, so trace is the sum of the entries of main diagonal. Okay, so you just can you can just add those entries of the main diagonal. Okay, so it is 1 plus 1 plus 5, that is 11. So this is the answer. Okay, so these are some short answer, like you can answer them within 1 minute. So that's why these are some short answer. And then we have some kind of mathematical term on the second part 2, and maybe further in part 3 and part 4. So let's see part 2. Okay, choice of the correct answer should be indicated by ABCD. So for part 2, this is also some short answers. So which of the following matrix is reduced row echelon form? So if you look here, we have the first pivot point here, but all the entries below this pivot point is not 0, right? Because we have on here. So this is not a reduced row echelon form. And the second option here, it is the first pivot point is 2, but we know that first pivot point needs to be 1. Okay, for RREF, the first pivot point needs to be 1. So this is also not a reduced row echelon form. So here the first pivot point is here, but if you look here, the second row, all the entries, they are containing 0, but we know that it needs to sit at the last, right? It needs to sit at the last row. So this is also not a RREF form. And then here, this is our first pivot point, and all the entries, all the so the second and the third row, they are all the entries, they are 0. So we can say that this is RREF. Okay, so I think the correct answer is D. Yeah, right. So here is the condition. Okay, so the correct answer is D, because all the entries below and above of the leading needs to be 0. I mean the leading one. Okay, and the pivot points needs to be 1, and the column that contains all zeros need to be last, need to be stay at the last. Okay, so that's why this D, it is our correct answer. So number 2, which is the linear equation in x, y, z? So linear equation, right? AB symmetric, AB equal to BA symmetric, AB equal to BA. AB equal to B, right? From left to right, x minus 2y. So what is the linear system, right? Which is the linear equation in x, y, and z? So linear equation means the power of x, y, z. Okay, or I mean the power of variable, they needs to be 1. Okay, like here the power of x is 1, power of y is 1, and power of z is also 1. So this is a linear equation. But here, if you look here, so root over x square means x square to the power, root over means x to the power half, right? So if you multiply 2.5, it will be x to the power 1. But here we have a sine function, right? So we cannot take sine, cos, or any trigonometric function in a linear equation. Okay, so this is not a linear equation. Although this part here, it is x to the power 1, but we have sine y here. That's why this is not a linear equation. And then here we have the power of variable, that is 2. So this is also not a linear equation. And here we have ln function, right? So this is also not a linear equation. Okay, guys. So can you understand? The answer is A, because the power of each variable, that is 1. And now let's go to the next question. Assume that A, B, and C are n n by n matrix and k is a scalar, then which of the following inequalities is true? So n by n matrix means it is a square matrix. So AB is equal to BA, right? So here, if you multiply, so you have to go from left to right and then up top to bottom, right? This way we multiply two linear system or two matrix. So AB equal to BA, this is symmetric, okay? I mean, so let's see how this symmetric. Symmetric matrix. So in a linear algebra, a symmetric matrix is a square matrix that is equal to its transpose. So that means if we do the transpose matrix, they will be same. Okay, I mean, let me give you an example. So if we have 1, 2, and 2, 1, okay. So if this is a matrix, so if we transpose this matrix, so transpose means the column will become row, okay? The column will become row. So we have column here on 2. So if I write down column as a row, so it will become on and 2 here. And then we have to write this column as we have to convert this column as a row. So then we get 2, 1, right? 2, 1. So you see, the matrix and the transpose matrix, they are same, right? On 2, 2, 1, so on 2, 2, 1. So this is called a symmetric. So okay. So if ABC are n by n matrix and K is a scalar, so we can say that this is not true, because this matrix is symmetric matrix. And for this one B, if we try to expand this as algebra